Have you ever stopped to think about triangles? I mean, really think about them. No matter how you draw one, long and skinny, short and wide, perfectly balanced, every single one is ruled by this one powerful magic number. And today, we're going to figure out exactly what that number is and why it's one of the most important rules in all of geometry.
And there it is, 180 degrees. Now, this isn't just some random number, you know? Think of it like a strict mathematical budget. Every single triangle that you can draw on a flat piece of paper has to follow this rule. The three angles inside it have to share these 180 degrees, no more, no less.
So, where does this rule actually come from? Well, it's not just a guideline. It's a core theorem in geometry. It's really the bedrock principle that lets us solve all kinds of geometric puzzles.
And here it is, in all its official glory, the Triangle Sum Theorem. It's simple, right? It just says if you take the three angles on the inside of a triangle, let's call them A, B, and C, and you add them up, the answer is always 180 degrees. It's a fundamental law of the universe, at least on a flat surface.
Okay, but why is it true? I love this little visual experiment. Imagine you have a paper triangle. If you tear off the two bottom corners and line them up next to the top one, they fit together perfectly to make a straight line. And what do we know about a straight line? It's 180 degrees. It's just such a cool, hands-on way to see why this theorem works.
Now, this theorem also gives us an amazing shortcut, a corollary, that's super useful in trigonometry, where right triangles are everywhere. If one angle is already taking up 90 degrees of our 180-degree budget, that means the other two angles have to share the remaining 90. In other words, they're always complementary.
All right, enough theory. The real fun is putting this stuff to work. Let's see how this one little rule becomes a powerful tool for finding missing pieces of a puzzle, starting with a pretty straightforward example.
Okay, here we go. Our first challenge. We know two of the angles, 40 degrees and 65 degrees. But what about that third one? Our mission, should we choose to accept it, is to find that missing angle. And how are we going to do it? You got it, we're going to use our 180-degree budget. So it's a simple three-step process. First, we set up our equation. 40 plus 65 plus our unknown angle, x, has to equal 180. Then we add up the angles we know, which gives us 105. And finally, just subtract 105 from our total budget of 180, and voila! Our missing angle is 75 degrees. Easy enough, right?
Let's try another one. This time, the problem gives us a huge clue. It's a right triangle. And that means we can use that awesome shortcut we just talked about, the right triangle corollary, to solve this way faster. See, instead of messing with 180, we know the two smaller acute angles must add up to 90. So we just set it up. 22 plus our unknown angle, x, equals 90. A quick subtraction, and we find out the other angle has to be 68 degrees. This little trick is a serious time saver.
Okay, time to level up a little bit. Don't let the algebra scare you. In this problem, the angles are given as expressions. But guess what? The underlying rule is exactly the same. We just need to solve for x first.
So what do? We just add all three of those expressions together and set the whole thing equal to 180. Now here's the neat part. The plus 10 and minus 10 cancel each other out. That leaves us with a really simple equation. 6x equals 180. Divide by 6, and x is 30. Now we just plug that 30 back into each expression, and we get our angles, 30, 70, and 80 degrees. And since all of them are less than 90, we know it's an acute triangle.
All right, let's talk about a very common mistake. It's a trap that's really easy to fall into if you forget about that fundamental 180-degree rule, especially when you're just sketching things out.
So here it is, the big takeaway. A triangle can never have two right angles, ever. And why not? Well, think about it. If you have two 90-degree angles, 90 plus 90 is 180. You've already used up your entire budget. That leaves 0 degrees for the third angle, which means you can't even form a third corner. The shape literally can't close. So remember, only one right angle or one obtuse angle per triangle.
Okay, so you might be thinking, this is all cool, but why does it matter in the real world? Well, it turns out this simple theorem is the secret ingredient behind some incredibly important technology we use every day. The power of this 180-degree rule is used in a technique called triangulation. And this isn't some obscure concept. It's used constantly by surveyors, by engineers building massive bridges, and yeah, even by your phone to figure out exactly where you are.
So how does this whole triangulation thing work? Imagine a surveyor. They start with a baseline, a distance between 2 points, A and B, that they know exactly. Then, from point A, they use a tool to measure the angle to some faraway target, like the top of a mountain. They do the same thing from point B. And just like that, because they know 2 angles of that giant triangle, the 180-degree rule tells them the third angle automatically. It's an amazing trick that lets them calculate huge distances without ever having to measure them directly.
So, to wrap things up, I want to leave you with a question to mull over. We've spent this whole time talking about how 180 degrees is the magic number for flat triangles. But what happens if you're not on a flat surface? What if you try to draw a triangle on a globe? Does the rule still work? It's a pretty cool thought, and it shows just how deep these simple geometric ideas can really go.